Hello, welcome. Let's start off by discussing some vocab related to angles. A vertex is where your angle is pivoted and you begin your angle on the initial side. Pivot, and wherever your angle ends, that's called your terminal side. In standard position, an angle will have its initial side on the positive x-axis and its vertex at the origin. Counterclockwise rotation generates a positive angle, while a clockwise rotation generates a negative angle. And here's an example of each. Initial side on the positive x-axis, you have an angle that opens counterclockwise, and where it stops is your terminal side. If you open your angle clockwise, then it is negative. Angles with the same initial and terminal sides are called coterminal angles. Let's look at some types of angles. The first one is acute, and that's where you have an angle that opens up somewhere between 0 and 90 degrees. If your angle opens up exactly 90 degrees, that's called a right angle. Many times a square will be placed inside to signify a right angle. An obtuse angle opens up somewhere between 90 and 180 degrees, and if an angle opens exactly 180 degrees, that's called a straight angle. Depending on the amount of angle you open will determine where the terminal side lands as far as quadrants go. Acute angles are quad 1, then you have a right angle. Obtuse angles are in quadrant 2. Straight angle, that ends on the negative x-axis. And then finally your bottom two quadrants. Quad 3 is if your angle opens up somewhere between 180 and 270 degrees. Quad 4 if your angle opens more than 270 but less than 360. Let's look at how to find coterminal angles. Let's determine two coterminal angles for 55 degrees. So let's first construct a 55-degree angle. If you have a compass, great. If you don't, when you sketch, just eyeball it pretty closely. This little angle in here is our original angle of 55 degrees. If we need to start and stop at the same place as 55, we can actually make a full rotation. How many degrees are in a full rotation? 360, that's right. So if you take your angle and add a full rotation, that will give you one coterminal angle, 415 degrees in this case. To get another one, you can open clockwise. So this little angle is still 55. If we start and stop at the same location as 55, we can do that by subtracting a full rotation from our angle. So if we take 55 degrees, which puts us here, and we subtract a full rotation, that takes us to an answer of negative 305 degrees. This is a coterminal angle to 55 as well. Complementary angles have a sum of 90 degrees. Supplementary angles have a sum of 180 degrees. This is an illustration of two angles that are complementary. Their sum would make a right angle. These two angles add up to 180 degrees. Supplementary angles are the sum of two angles that make a straight angle, or 180 degrees. Determine the complement and supplement of 72 degrees. Okay, so again, we just kind of eyeball, get pretty close, 72 degrees. A complement would be that little bit of a gap between the angle given and 90 degrees. So alpha plus 72 has to total 90. Subtract 72 from both sides, and your complement is 18 degrees. In order to create a straight angle, your supplement and the angle given have to total 180 degrees. So beta is going to be 180 minus 72, which is 108 degrees. Radian measure is another way to measure angles that's very useful in applications, and you'll see it a lot in calculus. A radian is the central angle where the arc swept is equal to the radius of a circle. Now that's a lot of words to say this. Imagine you have a circular pie or cake, and you cut out a piece for yourself or somebody else. If the length of the crust, that's your arc length, is equal to the length of the cut, that's your radius, then the angle you've created in here has a value of 1 radian. 1 radian is the angle where the cut equals the crust in length. 1 revolution around a circle of radius r corresponds to an angle of 2 pi radians. In degrees, it's easier to visualize. It's a 360 degrees, but in radians, that's 2 pi. Why is that? Your central angle is defined as arc length, or the crust, divided by radius, or the cut from the knife. If you go all the way around a circle, that's circumference, that's 2 pi r. Divided by r, those will cancel and give you 2 pi. Going back to the examples we did earlier in degrees, find 2 coterminal angles for 5 pi over 3. These are in radians. It's still the same idea. Your coterminal angles will start and stop in the same location, and you either add or subtract a full rotation. So if we take our original angle and add a full rotation, 5 pi over 3 plus 2 pi, think of 2 pi as 6 pi divided by 3. That still has a value of 2 pi. You've created a common denominator, so your total is 11 pi over 3. If you go clockwise, then you subtract a full rotation from your angle. 5 pi over 3 minus a full rotation. Again, 2 pi, think of it as 6 over 3 pi. 5 pi minus 6 pi is negative 1 pi over 3. Now, complement and supplement, remember complement is the angle that added to the original will give you 90. Supplement is the angle when added to the original gives you 180 degrees, which is pi radians. So to get the complement, which I'm going to call alpha, we take that angle, whatever it is, added to the original, that has to equal pi over 2. Pi over 2 minus pi over 6 doesn't have the same denominator. That's okay. 3 over 6 is the same as 1 over 2. Subtracting 3 pi minus 1 pi, that's 2 pi, over 6 reduces to 1 pi over 3. This is your complement. For supplementary, your supplement angle plus the original has to equal pi. And again, this is in radians. Our original angle is pi over 6. Subtract that from pi. Pi minus pi over 6. Again, create the common denominator. 1 is equal to 6 over 6. And that'll give us 5 pi over 6. Converting back and forth, degrees are arguably easier to visualize than radians. If your angle is in degrees, following the flow chart, you can multiply by pi over 180, and that will convert degrees into radians. If you're in radians and you need to go to degrees, then you'll just multiply by 180 over pi. Follow the flow chart. Okay, so let's convert 60 degrees, and then we'll convert 125 degrees to radians. 60 degrees, if we go to radians, we multiply by pi over 180. 60 over 180 reduces to 1/3. So that is equivalent to 1/3 pi, or pi over 3. Our second angle, 125 degrees, multiplied by pi over 180. 125 over 180 reduces to 25 over 36 pi. Going the other way, let's convert radians back to degrees. From radians to degrees, we're going to multiply by 180 over pi. Negative 2 pi over 3 times 180 over pi. The pi's cancel. 3 goes into 180 60 times. Negative 2. So 60 times negative 2 is negative 120 degrees. 7 pi over 6 converted to degrees. Again, the pi's cancel. 7 sixths times 180. 6 goes into 180 30 times 7. That's 210. If you have any questions, please send me an email, and I will try my best to help you out.